Quicksort algorithm is nothing but a divide and conquer algorithm used to sort the array. So quicksort algorithm is an efficient than bubble insertion and selection sort. So what we do in the quicksort algorithm, first of all we choose a pivot. So we can choose pivot any element of the array. It could be the first element, it could be the last, it could be the middle also, and it could be the random. So there is not a specific rule to choose the pivot. So let's say we choose our first element as the pivot. So we will write the array 6 7 1 2 3 4. So what would be the sorted array? 1 2 3 4 6 7. So what we do is we place 6 at its original position. So if we put the 6 here, now next what we do, we put the larger element to the right of the pivot element 6 and the smaller element to the left of the pivot. So what we do, if so we would check 7. So 7 is larger than 6, yes, so it would go here. 1 is smaller, so it would go here. So 2 is smaller, so it would come here. 3 is also smaller, it would come here. 4 is also small, it is come here. So this is the basic idea of quick sort algorithm. So this is the another example. Let's say 4 9 7 2 1 6 8. So here the sorted array would be 1 2 4 6 7 9 8. So here first element is 4, so its correct position would be here. Okay, so now we would take 4 9 would go in the right side of the pivot element 4, so here. And 7 is also larger than 4, so it would go here. And 2 is smaller, so it would come here. And then 1 is also smaller, so it would come here. And 6 is larger, so it would come here. And 8 is here. So here you see that the pivot element 4 is at its correct position. You can see here. Now what we do, we partition the array from the here. So and now again we would take the right side, the left side of the array as a one part 2 1, and 9 7 6 8 as the another part by partitioning the array. Now again we will apply the same algorithm or idea. We will take 2 as our pivot element, and what would is it set sorted array 1 and 2. Again the 2 would get at its correct position here, and 1 is smaller, so it would come here. Now you can see 2 is again came at the correct position, the pivot element 2. Now here you can see the element at the left side and not any element, so here only no, right side had no element. You can see only left has one element, that is 1. So now we know don't need to sort the array, as you know the array with one size is already sorted, so now it is sorted. So now what we do, we again sort this part of the array 9 7 6 8. Again we would apply the same idea. 9 is the pivot element, and what would be the sorted array? 6 7 8 and 9. So this is the sorted array, and 9 is the pivot element, so it would go here. And 7 is smaller than 9, so it would come here. 6 would come here, and 8 would come here. So here you can see 9 has got its correct position. Now again we will divide the partition the element around the pivot element. So here it is, here no element are there, so and here this is the partition of 7 6 8. Now again we would apply the same algorithm. And first of all you see the sorted array would be 6 7 8, and we place the 7 here. C6 is smaller, so it would come here, and 8 would come here. Now what you can see, the 7 came at its correct position. Now again we would partition the array. Now you can see there is only one element both sides, so it is already sorted. So after doing it, the element would get sorted. So this is the basic idea of the quick sort algorithm. So what we do basically here, we choose a pivot element. So here you can see 4 we have choose, and we basically keep the larger element to the right side of the array, and the smaller element always in the left side of the array. And the second step is what, we partition the array around the pivot. You can see here the 4 is pivot element, and after it came at its correct position, we partition the array. And after partitioning the array divided into two halves. Not the size doesn't matter, it would be same, or it can be like left side of the array would be larger. Here you can see it is larger or smaller, so it is not necessary ki it would equal every time. It can be larger or smaller. And in merge sort you can see that the element is always divided into two halves. So this is also a difference between merge sort and quick sort. So now I think you have understood. Now let's understand the basic implementation of quick sort algorithm. Then we will see the code part. So here I've taken an example array. What we do is we set the low variable to the part of the array, and the high variable to the rightmost part of the array. And what we do next is set the pivot element as the array of low. What is the pivot element here? 6. Now next what we do, we set the two pointer I is equal to low and j is equal to high, and we first run the I pointer till we get the largest element there, 6. So let's start the algorithm here. So what we see, we check 6, is 6 greater than the pivot element 6? No, it is equal to. So we would plus the pointer, so it would come here I. Now we will check 9, 9 is greater, so we will stop here only if we get the greater element than the pivot element. Now what we do, we apply the same algorithm in j pointer also, but we see the element which is lesser than 6 till we get the lesser element than 6 until we will run this pointer. So now we will check 7, is 7 greater lesser than 6? No, so we will minus the j pointer, so it would come here. Now what we see, 4, is 4 lesser than 6? Yes. So we would stop here only, and we swap the elements I and j, ith and jth element of the array. What would be the new array of the segment? It would be 6 4 2 1 5 3 9 and 7, and the I pointer is here and the j pointer is here. Now again we will apply the same. Now here you can see 4 is smaller than 6, so we will plus the pointer I and it would come here. And we see 2 is also smaller than 6, so here we will again plus the pointer and it would come here. And we see 5 is also smaller, so I would come here, and 3 also. And now here you can see uh, j it is overlapping to j, because as we plus the pointer it would come at the jth position, so it intersect basically. So what we do, we stop here only. And now the next step is basically, and we don't swap the element, we stop here only. And now what we do, we swap the pivot element and the array of I. So what we do see, first of all we can see the sorted array part of the array would be 1 2 3 4 5 6 7 and 9. And after swapping the array, what would become pivot element? Here you can see the 6 4, the previous array would be 6 4 5 3 9 and 7, and our I pointer was here and j pointer was here. And as we see that if we plus plus the ith pointer, it would intersect the jth. So what would we do? Basically, we stop here only and we swap 3 and 6. So what would be the new array? 3, 4, 2, 1, 5, 6, 9 and 7. Here you can see 6, the pivot element has got its correct position. Now again what would we do? We set the low point, partition the array basically around the pivot element. What we do? We set the low as the low only, but and uh, the high part is the partition minus 1 here basically. And here in another part we set low here and the high here basically. So here you can see the two part of the arrays. And what we do next is again apply the same algorithm at this part of the array and this part of the array. How we would apply this quick sort array, and what would be the low as it is, and for this, and the high would be partition index minus 1. And for this quick sort array, what would be the low? Partition plus 1 index and high basically. And we will apply the same algorithm of quick sort again. Now let's see the now we would see the pseudo code basically. So let's see the pseudo code. Pseudo code would be quick sort array low high. Here you can see basically if low is has less than high, and we get the pivot index by the algo function array low high. And after getting the pivot index, we again apply the quick sort array low pivot index minus 1 array pivot index plus 1 and high. We will apply the same algorithm. So what you are seeing basically, we are choosing the low and high, and after that we apply this pseudocode. Now let's see the algo function basically. So this is our algo function. What we are taking here, array low high. So what we do here basically we set the pivot element as array of low, and we would here run a while pointer while I is less than j, and also we will take here I is equal to low and j is equal to high, and we will run the while loop. And inside the while loop, first what we will do, again run a while loop, that array of I while array of I is less than or equal while array of I is less than or equal to pivot array of pivot. Okay, and also we would see that it don't cross the border. So how, what we do, I is less than I. Okay, so in this what we do, basically I plus plus, and again for the j pointer, what we do, array of j is greater than or equal to of array of pivot, and make sure that it don't cross the leftmost border. So j should be greater than low. Okay, so here what we do, simply j plus plus. So after doing this while loop, this both while loop, we swap the array of I and array of j. Now the next part is basically, after that we, if, while the big part of the while loop stop, we simply swap once again the array of pivot to the array of I. So this is the algo part basically. Now we would see the code, pseudo code. After that we will see the code part of this quicksort algorithm. I have missed condition part, that we would swap this array if and array j if I is less than j, then only we will swap this. So this is the condition we will put before the swapping the element. And also here the j can be less than or equal to I, and j is greater than equal to I. So it is not important that it should be less only, it can be equal to of high I, and j can equal to also to the low. So that's it, and that's it. We'll not see the code part of the quick
Now
sort.
let's see the code part of the quicksort algorithm. So here you can see I have taken the array 562397 basically, and the size of the array, and simply we will call the quicksort function. Yeah, here we will call the quicksort function, and let's see the quicksort function. Basically, as we see the quicksort function here we simply run a condition if low is less than high, and inside that we simply take the partition index. After calling this partition function, it would run the partition function, and simply we would get the partition index, and we will again call the quicksort function here to the leftmost part of the array and the rightmost part again, and after that our array would be sorted. Now let's see the partition function. So here this is the partition function. First we will take the pivot value. Basically this is the pivot value, as I have taken here the pivot value as the first element of the array, basically low. So and the pointer here I have taken low minus 1 and high plus 1. So while this is true, I simply I plus plus and till array of I is less than pivot, and simply array of j is greater than pivot, I would be minus the j pointer, and if the array of I is less than pivot, we simply plus the I pointer here. So basically it would go till we get the greater element than pivot. simply. And this will go, will we get the lesser, till we get the lesser element, then pivot. And after that, simply we would check if I is greater than equal to j, we would return the jth index. And first we would swap the array of I and array of j basically. And this is the basically the merge sort algorithm. And what would be the time complexity of the algorithm is? This time complexity is simply is big O n log n. Why n log n? It is simply because it is using divide and conquer algorithm. A divide and conquer algorithm simply take the log n time, and since we are iterating the whole array, so it would be n log n. And space complexity would be simply big open, as we are not using any extra uh, space, so it would be simply big O of 1 simply. So that's it. This is the quicksort algorithm, and I would end this video. Thank you for watching.